Let's make some observations about inverses. The very first thing that I think we can observe is the fact that, here we go, we're going to have some sentences going on here. Sentence number one. If some coordinate, let's point for an example here. If I have the coordinate 0, 2 on the original graph, then 2, 0 shows up on the inverse. So if AB is on the graph of some function, then you could probably finish this sentence for me. You know what's about to happen. We'll turn x and y around. Then BA is on the graph of its inverse, and we'll just use the appropriate notation there. Okay, we have also discussed this, so let's just jump in with the second one. The domain and the range. Domain and the range of a function and its inverse are swapped. Good to know. Okay, now we're going to get into some territory that we have not explored yet, and it's going to be a little bit interesting. Let's just keep talking about graphs, though, because this one has to do with graph, that one has to do with graph. Let's talk about one more thing that is graph-related, and I would like to point out just the way some of these graphs look. Let's look at this one, and we're going to turn it sideways a little bit here. And when we do, it's going to yield this funny-looking little thing here. Let's draw it. Here's that one. I'm tracing it. Here's that one. And then the original grid was here and was here. And I think we can draw something that's going to make some sense out of this thing. And here's the thing that we're going to draw. Where's my purple pen? There we go. Let's draw a line. Let's draw that line right there. What is that line? Well, I think that line is a mirror. That line right there is a reflection. It serves as the reference point for a reflection. So whatever is on this side is reflected onto this side. Whatever's on this side is reflected onto this side. And we can do the same thing with the graph down here. We could draw that line. Very quickly, I will. Let's make this kind of quick because I want to make sure we understand it. I don't want to... Whoops, missed a little bit. There we go. Don't want to waste too much time on this one particular one, as fun as it is. There we go. All right, notice that there is a reflection, and that reflection is around this line right here. So then the question really is, what is that line? Where is that line? This line right here, and notice it touches right there. And actually, it did the same thing on this one. It touched right here. So this line right here is a line that has a slope of 1. Notice if the scale and the x and y axis are the same, then basically this is like going up 1, going over 1, up 1, over 1, up 1, over 1. So this is a line that goes through the origin, so y-intercept is 0 and has a slope of 1. This is the line y equals x. So with that in mind, I could say that a function and its inverse are reflections over the line y equals x. And again, here's the deal. Y equals x right here. They're a reflection over the line. Whoops, there it is. Y equals x. So let's write that one down. A function and its inverse have graphs that are a reflection. Ooh, spelling. Spelling alert. I almost spelled rectangle. That's not it. Reflection over the line or about the line. Y equals x. Okay, we have a couple more observations, and we're going to go back to previous problems. It was number 6 and 7 on these. And I want to point out a couple things. And let's look at number 6 for just a second. The original function was linear, had a slope of 3/2. the inverse had a slope of 2/3. Okay, I hope you're noticing the little pattern here. The original function had a slope of -2/1. Okay, let's make that -2/1. And then the inverse had a slope of -1/2. So what are we doing? What are we doing? How do we take 3/2 and turn it into 2/3? How do we take -2/1 and turn it into -1/2? Well, layman's terms, we'd flip it over. That's not the mathematical way to say it, so let's write this correctly. The inverse of, there I go with my spelling again, I misspelled of. The inverse of a linear function with a slope of, well, we use m for slope, so we'll do that. Slope of m, okay, linear function has a slope of m, has a slope, the inverse has a slope of 1/m. It's the reciprocal. Okay, and then there's one more observation that we're going to explore in the next video, and it is really, really neat. I'm reluctant to go ahead and say it, but I want to go ahead and write it out in words, and then we're going to explore it in the next video. So here goes. The composition of a function with its inverse will always yield 29. No, I'm kidding. Will always yield the original input. Okay, what in the world does that mean? You'll find out in the next video.